Good morning, dear student. Uh, Myself, Amit Kumar Singh. Today we will discuss the insertion short. Before insertion short, we will discuss two type of shorting, which are also easy. And but before this short discussion of insertion short, we will discuss the bubble short, and after bubble short, we have goes on the selection short, and we will discuss the we have discussed here as a insertion shot one by one. We know that the bubble shot, the complexity is almost find n square, and after that finding in complexity in selection shot is also n square, but we have to discuss here in selection shot the performance is improved, and after that we have discussion short we have to discuss here in, and mm, if you have reminded I was telling you the performance is more better than bubble and selection shot, and we have to say that twice improvement of the over the bubble shot. So first we have to start the insertion shot, then we will discuss complexity, that means analysis of the insertion shot. Okay, so we will introduce the insertion shot. So we have to say the insertion shot work just like a name as a suggest. It insert each item into its proper place in the final list. The simplest we have to say the simplest implementation of this required two list structure: the source list, the list into which is stored in the item inserted, and to save the memory, the most implemented use in the place short that works moving the current item past to the already shorted item. Okay, and repeatedly swapping it with the preceding item until it is in the place. Okay, so we will discuss here uh, after introducing this. We will think what about this idea. Okay, where from this idea, and if you know about the playing cards, and then this idea is similar to shorting the playing card. Because of that, if we have some playing cards at the random, and after taking in hand, and then what we do, and then we will take a card and insert into at a desired place, that means as a correct position place. Okay, so the idea of the insertion rod is similar to the idea of sorting in the playing card. Okay, so insertion sort already I have to say this is simple sorting algorithm, sort on the array and then shifting elements one by one, just like a playing card, and following some characteristic here. That means it is first characteristic, it has one simplest implementation I have to say. It is efficient for small data set but very inefficient for large data items. Uh, how we it is understand, if we have take 10 playing cards, then arranging in ascending or descending order which you want, left right to left. Okay, but if you will take 10 not 10 52 cards, then arrangement is uh, complex, because of that card are 52, they are sequenced. So we have to say it is very inefficient for the large list. Okay, and the third point is here: insertion sort is adaptive, that it reduces its total number of steps if given partially shorted list, and it is increase the efficiency. That means he will if you have 10 cards, okay, and 8 card is all order, then you short only 2 card, okay, and one by one. That means if partially it is shorted, that means it is shorted, then it is increase the efficiency. Obvious, it is the efficiency. Because of that, you have to short only on 2 card, nothing else. Okay, so next point, it is better selection and bubble short. It is discussed previous lecture, and here we will discuss according the complex. So next further, and why thirdly we will discuss here why it is better than bubble and selection shot. Because of that, in the bubble shot and selection shot, comparison and sorting of the each element to the left or right, that means it is decided by ascending or descending, adjacent left or adjacent right. That means comparison. And if you are remaining, then you have to see in a bubble shot, comparison and swapping both are on every element, okay, if it is required. But in this insertion shot, it is not compulsory to uh, shorted every element. That is he wants it, sorry, he will discuss as a comparison, but not we have to say after comparison sorting is compulsory, okay. So it is better than both of this. So next point, it it space complexity is less, okay, this is right. And like bubble shorting and insertion short is also required a single additional memory space. That means we have to discuss in a single, no another memory location is occupied. That means no uh, uh, extra extra array is required for here. So he write this point. So next point is it is stable, as it does not change the relative order of element equal key, okay. So some point, these are the some characteristic of the short. And next discussion about how to work, okay. First we will understand how, then we have to discuss about the insertion short algorithm. So how to work insertion short, if we will take example, then we have to understand how to work as a insertion short, okay. So consider the elements in a short, to be short ascending order. Here we will take given given shorted in the ascending order. You have all shorted in descending order also, but we have taken here as a ascending order sorting. Then is how to work it is. So firstly, it select the second element. Because of that, he is select the second. Why? Because of that, how to compare the first element to first element? Because he know the first element is lesser uh, or greater. That means then for comparison, have take first second element of the array, okay. Then second point, he will check whether it is smaller than element before. That means if we have to consider 6 2 11 7 and 5, it is a sequence of array, and the set of array. So 2 second element is here 2, then 2 is checked before elements. That means before 2 is 6, and he check it is smaller or not. If it is smaller, okay, since if it is smaller, then further we have to swapping. Otherwise we will not swap, okay. Since 2 third point is here 6, since 2 is less than 6, so it is shift 6 towards right and place 2 for it, okay. The resulting of as is Swapping after swapping, 2 6 11 7. Okay, then this is first pass or first iteration, we have to say first pass. Okay, and then next second pass, and then select the third element. Okay, and if we will select third element, and if you have any problem, then we have to use this array here, 2 6 11 2 6 11. 1 minute, given a 1 minute. Okay, we will discuss the second pass. We will select the third element. Okay, second element in the first pass, third element is a second pass. Okay, so we will select the element which is 11. This array is written by me, this is 11. Okay, so here 11 is selected, and check the smaller than the before element. That means if we have consider this is 11, if we have, sorry, okay, okay, we will select the 11, that means this element. That means the third element, if you have to select it, then before third element, every element to check and compare with 11 key, that is shifting take place or not. That means before 11 we have to check 2 and 6 both, and after checking 2 and 6, we have to find here no shifting take place. Because of that, 11 is greater than both 2 and 6, so no remaining change in the any change in the your uh, array. So third pass is here, it is selected the fourth element. That means you have to select the fourth element, and we have to write this is 7. Okay, okay, this one is 7. Okay, and it check whether it is smaller than any of element before it. That means before 7, all the element can be compare, not swap, only compare. If it is required to swap, then you will swap, otherwise only comparison. And after 7, we have to check 2 6 11. Here 2 and 6 both are greater value, but sorry, 2 and 6 both are smaller than 7, then there is no swap is take place. First we have to check and compare with 11, and 7 is less than 11, so shift 11 towards right and 7 before it. And after it, we will check 7 compare with the 2 1 by 1, but 7 is greater than both element, so more shifting take place, and the resulting array is this one. Because after shifting is 7, then 2 6 7 11 and okay. So we will discuss next. So we will go for next page, and this is fourth iteration. Then we have fifth element, this is last element, this is 5, and we will check before fifth element to compare with 5. Then since 5 is less than before element, just like 6 7 and 11, and 2 is also here, but 2 is less than 5, so in comparison is here, is executed here, but shifting is not at that from 2, so it is shift from 6 7 11 towards the right and take place 5 before all these all these given greater elements. Then resulting list is 2 5 6 7, and this is a finely sorted ascending order element. So this is the procedure, this is the theoretical procedure how to work the insertion sort. Okay, I hope you have understand theoretically how to insertion sort work. And further we have discussed the insertion sort algorithm. And so we will start the insertion sort algorithm. uh, in insertion sort algorithm, before we will discuss the theoretically how to work the insertion sort. So insertion sort algorithm, we will start. First we have to first step, insertion sort, that is a you know, a is the array. And the first for loop I is start with the 2 to a of, that means array of the length which is given by user, or array is given here. So and we have to set a key value, and in an example we have to discuss what is the key and what role play here key. Then key is a of ith value, and which is start with the 2. So here it is 2. And here we have to say key a of I into the sorted sequence a of I 1 2 3 and so on, I minus 1. And so I so we will discuss just one point is here, error. I is start equal to I minus j minus 1. Here the value is right value is j equal to I minus 1. Then while condition we will check here, j is greater than 0. And with this condition aj is greater than value of key, then you have to call the swapping. ठीक है ना? It means a of I is less than or equal to a less than or equal to that is assigning value. aj value is assigning of I plus 1 values, and jth value is as a I value is equal to j minus 1, and a of I j plus equal to key. So for better understanding of this algorithm, we will discuss a example. I hope you will understand. So we will take a example. So using the my, so we have to take, that means we have take a array. This array element is 2, 13, and next value is 5, and next value is 18, and the next value is 14. That means we have to consider this array 13, 5 and 18 and 14. That is we have to if we have to so in the array, then total number of element equal to 5. That means length of array is 5. Then we have to start with the for loop. For loop is start with the j is started with the 2 length of array. That means j is started with the 2 to length of array. Length of array is equal to 5. Okay. And assigning the key, this is k, and this is key of jth first value. That means aj. Then aj is here, j is equal to 2. Okay. So a of j, this is jth value is 2, and second position the value is 13. That means key is 13. And after that I set the value of I, and I is equal to j minus 1. And we know that j is start with the 2, then 2 minus 1, this is equal to 1. This is okay. Okay. And then we will call the while condition. And while condition is says we will call while condition. Then while condition is called I is greater than 0, and a of I is greater than a of I is greater than a of I is greater than key. This is okay. First condition, I is greater than 0, which is okay, done. Okay. And then second condition, a of I I is 1, a of 1, value, second condition, a of 1 value is 2, and 2 is greater than key value. Key value is 13 there, 13, then 2 is greater than 13. No, that means false the condition. That means no change in the no change in the position of 2 and 13. That is okay, that is right. You have to say 2 is less than 13. Comparison is here, but no no desired position is changes. So we will discuss next. So we have to erase this values, okay, and next part of the discussion. So now the value of j is incremented. J is 2, and go for next value. J is start with the 2 area of the length. J is incremented, then j if when j is incremented, then jth value is 3. Okay, this is 3, and I set the key. A of j is key value. This a of j, this third value, the key value is 5. You have to understand, okay. And so set the ith value. I is equal to j minus 1. This is j is 3, then I equal to 2. Obvious सी बात है, 3 minus 2 or minus 1 is equal to 2. So while condition is check. I is greater than 0. This first condition is correct, and then second condition, what he will say, a of I is greater than key. This is second condition, both condition in the while condition, okay. Then I is greater than 0. This is right. A of ith position is 2. This is 13. Then 13 is greater than keyth value. This is 5. This one is right, okay. The condition is true. Then for the position swapping is here allow. Then what is the position swapping? A of I plus 1, a of I plus 1, I value is 2. Then a of ith position will take a of ith position, will take a of I. A of ith value, that means a of ith value, this is second value. That means we have to write here a of I plus 1 is assigning with the value of a of I, okay. Then a of I second, this is 13, okay. 13 is assigned to the a of I plus 1. I plus 1, this is 2 plus 1, this is 13 is here, okay. 13 is position of 5, and then I is equal to I minus 1, okay. And then I equal to I minus 1, and a of I plus 1th position is occupied by key. Then key is 5. That means this position is swapping to each other, and I is decremented, okay. I is 2. Then while condition is terminating when जब in both condition one of them false. Then I is decremented 1. I is 1, then 1 is greater than 0. This is okay, and then next swapping is called here. So if you have to discuss again, then you have to next iteration no change, and after that if j is incremented to the value of equal to position, then easily you have to understand overall this question, okay. We have discussed next point for the step by step as a ppt model. We have to consider the same example which have to theoretically we have to understand. We have illustrate this value graphical representation here for the insertion short. Then same question I have considered, and shorting is also same. We have shorting in the in order of ascending order, and the above is a straight order. So first step, I just start with the one and go for next. Okay, and I is start when the, that means key is set on the second position. This is first, this is 2, and he is compare before 2. That means he have compared to before 2. Then he will check 2 is less than 6. So 6 next value is 2 6 11 7 5. And after seeing this 11 2 6, this is swap. And then next key value is 11. Okay, and after seeing this 11, before 11 we have to see that 2 and 5 both are smaller than 11, so no swapping is called. That means while condition is not true at this time, so we will discuss here. So we have to write here conditions to iteration. Okay, and you have to see, and working of the inner loop, I is equal to third position, and one by one we have to sorted the sub array is here. Okay, so loop become finalized, and we will find the sorted sub array with the each loop one element is placed at the current location in the sorted sub array until array is completely short. Okay, and we have to see here pseudocode of the insertion sort, and we will discuss here. I is start with 0 to n minus 1, and we have to set a value which is jth value first, and we have to go for set the ith value which is less than sorry, which is start with the equal to j minus 1, and then call the while loop and check two conditions. You have tuple here as j is greater than, and consider I is greater than 0, and uh, if I is greater than, or sometime here we have to write j is greater than condition aj less than aj minus 1. This is key after finding this value, and swap, otherwise we will not swap. Okay, this is the swap condition, and this is the code of insertion sort. You have to easily understand this. This is for loop, and for loop start with the 0 and go for the less than length of array. Because of that, indexing is start with the 0, then we will not go for exactly go for length less than length. Because of that, we have to consider a array which is start with index number 0. So here, and while condition same as it is here, and then swapping the value. So best time to use the insertion chart. Okay, when we data set are relatively small. Okay, we have to discuss this point in the feature of insertion short, and we will discuss in the insertion short this is moderated efficient when you want to quick easy implementation, not hard to code in short, and mostly when data sorted is mostly sorted early. And the worst condition of use when the data is larger, when data is larger and data is absolutely at the reverse order. So we have to say this is uh, overall we have to check before analyzing the insertion sort. I will take an example, and you have to easily understand the analysis of the insertion sort. This is the insertion sort algorithm, and how to find the best case. If you have to consider, take an example, if you haven't consider 1 2 3, 4, 5. This is the array and element of array. Then I have to say you have to sort this element as a ascender in using the insertion sort. Then what he will do, insertion sort, first come to the 2 and compare with the 1, and he compare but not swap. Swapping is not necessary, and then go for this one. And basically he is comparing the first value, this is 2. Okay, when he comparing the first left value, and if it is greater, then others are not to be compared. Because of that, we have no before this value, this is lesser than this value, then how you can say this is not lesser than he? So and so on, we have to see last one. This is the best case of the analysis of this algorithm according to asymptotic notation. So next one is, and next, how to we have to say what is the worst case condition. Then worst case and average case both are order of n square, and the worst case, if the given array is totally in the reverse order and finding the ascending or descending order, that means I have to say if the element here, you have to see the element are there. This one is this is 5 4 3 2 1. This is given array, and this array says that you have to sort this array using the insertion sort, and ascending order. Then first you have to know, according to j, j is start with the second to n, that means total number of element. Then first I have to write 5 4 3 2 1. That means what he can do, uh, is the second position. Okay, this is the second position he compare with, and after comparing he find it is less, this value is less, so it is swap. That means if completely right, this is compare, this is movement. Okay, this is compare, this is movement. That means then if j is here, j is start with the 2, that means 1 2 3 4, oh, sorry 4, and this is 5. Then j is on the position 2, then j first time 2, then one comparison and one movement. Okay, one comparison, one moment, then total is 2. Okay, the and when after this, when j is on the third position, then both 4 is there, 5 is there, but after 3 it is compare, it is less than 5, and this is here, then again compared to the 4, and then placing third is here. That means two comparison and two movement, that means total is 4. Okay, and then when he will go for a next position, this is fourth, then fourth I equal to 4. That means before 2, all these elements are compare and move one by one. That means 3 compare and 3 movement, this is equal to 3 plus 3, this is equal to 6. That means one thing. Okay, I have right. That means here this is comparison, this is movement, or this is total. That means when j is 2, that means one comparison, one movement, this is total is equal to 2. And next one is 2 compare and 2 movement, this is equal to 4 after addition, and 3 compare and this is 3 movement, this is equal to 6. and so on. If the number of element is n, then total number of element, that means n comparison and n moment, this is 2 into uh, 2 into n. Okay, that means this is right, 2 into 1. Okay, this is equal to 2 into 2. Okay, this is equal to 2 into 3. Okay, 6 is right here, and then and so on, 2 into n. Okay, and this is added by you, you will find, you will find 2 1, 2 into 2, 2 into 3, and after addition, this one, this one, this one. And how to write this one is, this is right here, this like is, we have to common 2, and we have to write common, this is 1 plus 2 plus 3 and so on, 2 times, or less than 2 times. And if I have to consider this is an element, then we have to compare with the n minus 1, and after adding this value, we will find 2 into 2 into n minus 1 into n divided by 2. There are, cut it here, then we will find n square minus n. This is polynomials higher degree, this is order of analysis of the condition. This is worst case condition when we have to find this value. Okay, that means worst case, at the worst case condition, insertion sort given the n square. Okay, if fully reverse order array is given, and you have to find its reverse order ascending or descending value. So this is the worst case. And before this we have, sorry, before this we have to discuss best case. And if you have to understand about the best case, then also you have to write, this is this one is okay, which using attenuation, this is compare, and this is movement. Okay, this is compare. So we have to given a array 1 2 3 4 5, and we and this given array used to insertion sort and finding the ascending order. Then what, j is what, j is here, and what he will do, he compare like 1 2 3 4 5, j is here, then what he is comparing here, compare one, and he will go next, but no swapping, that means no movement. Then comparing is here, but movement is no. And then j is here, then first element is compare, one time I'm compare, and he will know others are smaller than this comparing is 1, movement is no. That means the value is n, then comparison is 1 1 1 1 1 to the n minus 1 times. That means order of analysis is n. Overall this is n times, that means n elements, n comparison, and over and okay. This is in the worst case. If you have to consider swapping is constant, because of array already sorted order, so comparison is 1 1 1 at a time element. We have to also write here order of this analysis, this is order of, this is 1, this is constant. Okay, so this topic is, I hope you have to understand what is this, and how to analysis this case, average case. So thanks to all of you. So we will discuss in next lecture as a heap shot, and thank you.